Hello, I'm David Dipple. This is 1316 Trigonometry. We're dealing with Chapter 3, Section 4, which is arc length and area of a sector. This is my email address, and I work at Lone Star Montgomery. The first thing we need to do is define some things. Arc length is if you have a circle, the arc length is the distance you're going to walk if you were able to start at one end and walk along the curve. The curved distance that you walk is the arc length. And there's a formula for that. S, the arc length, is equal to r, the radius, times theta, the angle in radians. Now this is just rearranging the formula we had before. Theta is equal to S over r. We just rearranged it so S is equal to r theta, where S is the arc length. That's the distance along the curve. R is the radius, and again, theta is the angle, but it has to be in radians and not degrees. You're going to have to convert that. Now suppose we have a Ferris wheel, and the diameter is 250 feet. It may be a very large Ferris wheel. We want to know the distance is traveled by a rider, because the rider is going around the circumference of the circle, and suppose the Ferris wheel goes 45 degrees. So I wrote the formula S is equal to r theta. And I'll draw a circle, and 45 degrees, that's like if you start at the bottom. You can start anywhere, but usually your Ferris wheel will get on at the bottom. And you go 45 degrees, which is about that far. So we know how far the rider is going to move as he goes along this curve right here. So we know S is our distance that we're going to travel. Radius is 250, and we need to convert 45 degrees into radians. So to do that, you should get pi over 4, because 45 degrees is pi over 4. That's in radians. Then if you take your calculator, 250 times pi divided by 4 is about 196.3 feet. So this person is going to go about 196 feet in that 45 degree arc. Now, what's the distance traveled by a rider if they goes 105 degrees? We do the same thing. S is our arc length. Radius, same radius we had before, 250. And theta is now 105. Take 105, multiply by pi, divide by 180. And here's our picture. If you start at the bottom and go all the way around, you'll get up around here somewhere, 105 degrees. Now I reduced it to 21 pi over 36. You could reduce this to 7 pi over 12. Multiply this out, and your decimal will be 458.1 feet. So that's how you find the arc length, the distance you go around the curve, the arc part. Now the area of a sector. The area of a sector is like the slice of a pie. It's the amount of pie that you physically get. That's the area this time, not just the perimeter of the circumference. So if you have a circle, this slice of pie that you're eating, that is a sector. And the formula for that is going to be A, since it's an area, is 1/2 r squared theta. Now it comes from the pi r squared formula, except that we only have part of a circle, so we have, that's where the half comes from. And the theta comes from the angle in radians. So again, it's 1/2 r squared theta. Theta is going to have your pi in it. So A is the area, r is your radius, and theta is, again, an angle that is in radians. Okay, suppose we want to find the area of a sector. If the radius is 5 and the angle is 42 degrees. Now, if we're in degrees, we have to convert that. So we have our 1/2, our radius is 5, and our angle is 42 times 180, or pi divided by 180. And when I took the 42 times pi divided by 180, I came up with 7.330 for my angle theta, 1/2 5 squared. So the 42 degrees I converted into radians by multiplying by pi and dividing by 180. Then if you multiply this out in your calculator, 1/2 5 squared 0.7330, you should come out with about 9.16. That should be square feet, not feet. What's the radius of a circle? Suppose we have information that the area is 1.072 square centimeters. The angle is 15 degrees. What's going to be missing this time is our radius. So A is our area. We plug that in. 10472, 1/2 r squared. Theta is 15 degrees. We could have used 15 degrees. You could have used taken 30 degrees and then divide by 2. Just convert it into a decimal. 15 times pi divided by 180. You should get 0.2618. And then when you solve that, if you take the 0.2618 and divide 1.0472 divided by 0.2618, multiply by 1/2 and take the square root, you should get 2.83 for your answer. Sorry about that. So that completes everything in section chapter 3, section 4, which is area of a sector, which is what we just did, 1/2 r squared theta. And the other formula was arc length, which was r theta.